Welcome. We will look at the importance of soils briefly and then look at degradation, what causes degradation, and we'll distinguish between what's called immediate and underlying or fundamental causes. And then we'll say a few things about soil management, especially with a focus on building models because we have been analyzing fisheries management before and we are looking for ways to analyze management or processes. So it's good to always think of how you would model something, and soils is another example. So we'll try to create or draw parallels between what you would do here and also what we did before. And finally, we'll finish by talking about what people think about soil management, especially whether farmers manage soils optimally or not, and if they don't, why. Because we have been talking about fisheries and we had two cases where in one case it was managed as a private property and optimally, and in another where it was completely the opposite, where the outcome was socially undesirable, which was the open access problem. So when it comes to soils, what could we say about its management, especially in countries where there is a lot of soil degradation because of poverty? Now, in terms of soils, there is a few useful resources out there that are easy to access and listen to, especially a couple of videos that I have put from the FAO, Food and Agricultural Organization. And if you click on the video, the blue link, it will take you to the YouTube. It's a very short one talking about the fundamental facts about soils. And in this case, I have taken the image which shows what soils are composed of, and what you see here, this is just for an average soil, is that the bulk, almost 50%, is minerals, and then you have a quarter water, a quarter air, and a small portion, 1 out of 20, is organic matter. Of course, when you go to different parts of the world, these ratios would change, but that's just an average. It's a good summary, and there is more in the video, not just what you see in front of you here. Now, soils and their functions. What do soils do? Well, soils are the basis for agriculture, and agriculture is what gives us food and fiber. So soils are fundamental to our capacity to produce food and our capacity to produce other biomass, whether it's raw materials from agriculture, for textiles, or for other things. Source of raw materials directly, not through agriculture, but directly, because obviously that's where we have a lot of minerals, whether it's bauxite or many others. That's their second function. Of course, soils are home to a quarter of the species on the planet, so they are a biodiversity habitat. And finally, they have many environmental functions, including the storage of carbon, filtering, buffering, recycling, and so on. And there is a video link there where we have something about soil and carbon sequestration, and I encourage you to go there and listen to the video. Now, when we talk about soil, we are always thinking about whether it's managed well, whether it's being degraded. And of course, I have 3 pictures here, one from Tanzania, a farmer in Africa. She is looking at her land where she's growing something, but the land is obviously degraded, and that's a poor country, but also in rich countries like the US and Australia. So the left one is the US, the bottom one is the one from Northern Australia. So if you look at the US picture here in the middle, then what you see is it's farmland because corn is being grown, but the land is being washed away. And it's the same with the tree here that has lost its soil because of erosion. So soil degradation is a problem in many parts of the world. This is just a visual demonstration of that, but erosion, water and wind, is a serious threat to soil. The other one is nutrient depletion, and that means that farmers take out more from the soil than they put back in, and that means over time it gets degraded, its capacity to support vegetation goes down, and if that happens, then it's prone to erosion. So you get more problems. Acidification from the way soils are managed, the use of fertilizers, then over time they can become acidic. Compaction is a major problem in mechanized agriculture, where you drive tractors and combine harvesters and so on. And because of the weight of that machinery, the land, especially the top 10 centimeters, becomes compact and it doesn't allow water and air circulation. And that means the soil isn't fertile, but also it's prone to erosion and so on. Pollution is another one. Soils can be contaminated especially in places where there is a lot of chemical use and so on, or something else is happening like oil production in places such as Nigeria and so on, and then you get the pollution of the soil. Water logging can be a problem. Too much application of water or not proper water management leads to water logging, and of course that will kill the vegetation, and that will have its secondary effects on soil quality. And finally, irrigation salinity is a problem. When you are in parts of the world where agriculture is heavily dependent on irrigation, farmers are applying irrigation water, the water evaporates, the soil stays behind, it accumulates, and then that causes problems. So all these are threats to soil. And if you look at a global picture, this is a paper by et al. From 2008, and it's trying to show how much soil in millions of hectares is affected by these different factors, causes of degradation. And what you see here, it doesn't matter whether you are in a poor country or a rich country, Asia, West Africa, Africa, and North America, and so on, or Europe. There is a lot of land that's affected by wind and soil water erosion. So worldwide, we have 1 billion hectares of land that's affected by water erosion, and about 500 million hectares that are affected by wind erosion. Now, the next major cause of degradation is nutrient depletion, but as you can see here, that's a poor country problem where farmers cannot afford to invest in soil fertility or use fertilizers, so they take out more than they put back in, and then what you have is you have nutrient depletion in Africa and Latin America and the Caribbean. You have other problems as well, salinity, which is common in Asia, West Africa, and so on. But if you look at the other two I won't talk about here, contamination, that is more a developed country problem where there's a lot of chemical use. And the same thing with physical damage to soils, which is the compaction type, and that's again in the mechanized agriculture, what's in the developed world. So what you see here is problems in Europe. So this is a good summary. So soil erosion is not an old problem. Soil erosion is still around. So what causes this degradation or these problems? Well, we can distinguish between direct or immediate causes and fundamental or underlying causes. So let's first talk about the direct or immediate causes. What causes this degradation on the surface? Well, one is bad water management. We have groundwater depletion or irrigation and so on. And these water management problems lead to soil or land degradation problems eventually, whether it's irrigation salinity or whether it's the drying up of the land, the death of the vegetation. If you take out all the groundwater, the vegetation is going to die. And if the vegetation dies, the soil is going to be degraded. Deforestation is another problem, which is common in many parts of the world, developed countries, even sometimes. And because this deforestation, what you get is you have land being exposed to the elements and erosion and so on, and then it gets degraded. Shifting cultivation is another one. This is a developing country problem where farmers, they farm land. After a while, they cannot maintain the productivity or the fertility, and then they say, okay, let's move on, cut another forest, and start growing crops. And when that one becomes not fertile enough for them to stay on, then they will move on. And that's slash and burn agriculture or shifting cultivation. There is another one that's also common in many parts of the world, and that's overgrazing. Overgrazing, here on the picture, you see a few sheep, goats, sorry. Of course, this is just the front part, but what you see is you don't see any vegetation. And that's from Somalia, and all you see is dust and soil and sheep. And what that means is livestock eat up the vegetation, and when they eat up the vegetation, the land gets degraded. So livestock is a menace to vegetation and the land. So the carrying capacity of the land is surpassed. And what is in here is an extreme case, but that's very common in countries where even when you look at the landscape, you still see vegetation. Livestock numbers are huge in some countries relative to the carrying capacity of the vegetation. Another problem is people farming land that should not be farmed, what we call marginal land. It's called marginal land because it's fragile land. It's land that if you start to plow or cultivate it, it would degrade and deteriorate. Unfortunately, in many parts of the world, including some parts of Europe, people have to use land. There is shortage of land, and they farm marginal lands. Another one is bad tillage practices. So this could be a case where in some countries farmers just keep plowing the land to prepare it for planting, but that plowing leads to soil degradation because it's destroying the structure of the soil. It's leading to the loss of nutrients and moisture and so on. And eventually it does more harm than good, but they have to do it because they don't have ways of controlling weeds and so on, and that's how they have been farming for thousands of years. But that becomes a problem. Of course, in many parts of the world now we have no tillage agriculture. So if you look at places like WA and so on, tillage is now becoming something that's basically history in many parts because farmers can put in crops without having to turn the land over. Inappropriate crop rotation is another problem because farmers can depend on monocropping. That means growing the same crops over and over because they need them for food or they need them for cash. And that means growing cereal such as barley and wheat and so on year after year. But of course, if you do that, you deplete the soil. You don't get the soil the chance to recover by leaving it fallow or by growing legumes that fix nitrogen and so on. So this is another problem where the profit motive is bad to land management. Poor fertilizer and nutrient management, it's related to what I just said, but obviously when you say fertilizer, if people don't use nutrients, if they don't put in nutrients, then that's obviously going to deplete the land. But it's also how you apply the nutrients or the fertilizer, because if your management is not good, you could apply the same fertilizer, but it's less useful because the way you apply it or the timing of the application is important. So you have to know when to apply it and how to apply it. So those are the direct or immediate causes. What is a fundamental or an underlying cause? Well, if you look deeper, what's behind what appears to be the problem on the surface? That's what we are talking about here. And obviously one is land availability, land not being available in sufficient quantity. That means it leads to intensive land use. So people don't give the land a break, or they use a lot of chemicals to pump out better output from it. And that's going to lead to soil contamination, soil degradation, and so on. Of course, throughout the world, especially in rural areas in developing countries, we have population pressure. And that simply means you have to subdivide the land, and people are going to be farming smaller and smaller plots to support a family. And that is going to lead to soil degradation because they are trying to earn a living from a land, but it's so small and they don't have capacity to manage it very well. And poverty is another one. Of course, poverty has many effects. It's not what I just said, farmers not being able to invest in the quality of the land, but poverty means they are going to depend on the forest for firewood. They are not going to invest in conservation. They are just not going to put things into the land or into what would be useful in the future. They don't have electricity. They are going to use firewood, and in many parts of the world that leads to a degradation of the landscape and the vegetation. But also they will depend on livestock, and all they have to feed the livestock, or suppose the livestock is the land and the vegetation, and that again is not good for the land quality and the vegetation quality. Finally, what governments do in terms of the rules they put, what we call institutions, and also the policies they in the form of how they manage people's behavior in terms of what they buy and sell and how and so on, all the policies are important. So in many countries, land tenure is not necessarily secure. So if you have land in Western Australia, then it's your land. No one is going to take it away, and private property is secure. But land in many countries is not secure because maybe the country is a socialist, something like a socialist, or it's not a socialist, but then even if it doesn't say that land is owned by the state, not by individuals, it still doesn't guarantee people the right to use the land indefinitely or the right to transfer it if they don't want to use it. So you have countries where they allow you to own land, but they cannot buy or sell it. Okay, that's one. Or in some countries, you cannot even own the land, you lease it from the government. So under those circumstances, it's difficult for farmers to invest in land quality because they don't know if they will benefit from what they put in. So this is a major problem. But if you also look at other aspects of how governments affect behavior, if you look at their agricultural policies, how they manage foreign earnings, especially foreign earnings coming from agricultural exports, which they can manipulate in terms of how much is passed on to the farmers by using exchange rates. Okay, not all countries use flexible exchange rates, so the market value of the local currency is not determined by markets, by demand and supply. It's determined by government policy, where they have fixed exchange rates, and then they use that to extract money from agriculture, so that they can pay for the other things they need. But then that impoverishes farmers, and this has been a big problem in the 70s and 80s, and still is a problem in many parts of the world. Environmental and economic policies also in many different forms. So if you go to developed countries, governments can encourage more production, places where there shouldn't be more production, but that means farmers will pump in chemicals to keep up yield because the governments encourage it. And that's not good for the land and the environment. Whereas in other countries, it could be the opposite. Farmers are just struggling to survive, and then they don't put enough effort into conserving the land. So all this, whether it's developed countries or developing countries, policies and institutions can be an issue. So these are what we call the underlying causes behind land and soil degradation. Now, it's useful to ask a question. Is soil a renewable resource? That means if you affect it, if you decimate it, or if you reduce it, does it grow back? Well, of course, it's a renewable resource, but within a threshold. But you will see in some of the videos, they will tell you it's not a renewable resource. What they mean is, if it's degraded seriously, it might not come back. That's what they mean. But technically speaking, soil is a renewable resource because it can recover, but it cannot recover if its structure is damaged so much that it's not going to come back to the same state, because even if you put in effort, the effort is not going to be productive. So for example, if the land is already degraded, the structure is destroyed, it's falling apart, and then you put in fertilizer or whatever, or you try to establish vegetation, either that takes huge amount of effort or it doesn't work. So managing soil is critical to the profitability and productivity of the land, and that's something that you want to maintain, which means you don't want the soil to be degraded to the point where it becomes a desert or gets destroyed completely. So we have looked at the degradation of the land and what it means and what it's caused by and so on. Now, if we look at people's behavior, we need to ask, if soil is important to agriculture and society, why is it not managed sustainably? Do farmers have an incentive to manage the land? And if they do, why are they not managing it sustainably? Or is there something about poverty, poor versus other farmers, that shows that maybe poor farmers cannot manage the land optimally? So these are important things to answer. And what do economists think about how farmers should manage soils? And how does that prediction of behavior, based on the idea of a farmer being a rational economic agent managing soils for profitability over time, how does that prediction compare with what's happening on the ground? How farmers actually manage soils? Okay, do farmers behave the way economists think they should? And if they don't, does it mean there is a case for policy intervention, which means governments should do something? They cannot just let things be determined by private individuals, because the actions of private individuals are not generating outcomes that are socially optimal. Okay, the best social outcomes, just like we saw with some types of fishery management. So these are important questions to ask, and like everything else, like fisheries, like pollution and so on. Soil management is a social problem. So if you are going to analyze soil management by farmers, where do you start? What do you look at? Well, the first thing to notice is that it's a dynamic problem. What you do today affects what happens tomorrow in terms of productivity. Therefore, you should consider in your modeling how future benefits and costs depend on current management practices. Just like we did with fishery, what you harvest today determines how much fish you live in the ocean and what your fishing costs are next year and how much you can harvest next year or next period, next month. But what happens to the soil isn't determined by just what farmers do. It's also determined by other natural processes. So we have to also acknowledge those other elements in the dynamics. So we are not going to build a model, but we'll just identify some aspects of it, because now we have begun modeling things. We modeled fisheries, so we know how to do stock modeling, at least for some cases. We have looked at fishing effort. We have calculated profits, revenue, cost, and so on, identified what's called maximum sustainable yield and compared it with what's called maximum economic yield and so on. So we have done modeling. Now, when it comes to soil, what could we do? What would the elements of the model be? Well, the first thing is, what exactly is the stock in the case of soil? Well, it will be something, a measure of the health of the soil or the quality of the soil. Let's call it a soil quality measure S, or a nutrient stock. It could be. Of course, soils have different elements, but we'll just simplify things and call it a stock. Now, that stock will depend on natural processes and how we manage the soil. And those processes are going to augment or deplete the soil. And if we look at those, they include land cover, for example, what type of land cover we have. And if it's farmland, agricultural land, that land cover is actually our crop. It's not the native vegetation or anything. So what we are trying to produce out of the land, output is important. That's something we control by how much fertilizer we put in, what type of crop we put in, and so on. So we are part of the process. Nutrient inflow is important. Soils are not static, they are being moved around. If you have erosion, then you might be losing soil or you might be gaining soil depending on where you are on the landscape, and that net inflow is hedged. And that has to be part of your model. So that means when you are studying soils, you are going to be thinking about a lot more things. Okay, and also conservation effort. And here we are going to just summarize conservation into some measure called E, although we know that's something that includes labor, capital, using stones and whatever you have to use to conserve soil. But we'll just make it effort because we are interested in looking at the essential elements without getting into the details. So that's where we would start. Now, what's going to happen is, because we are talking about what happens to the soil, well, we have to think about erosion, because there is always erosion. Either erosion is bringing soil into the land or taking it away. And scientists have a way of modeling erosion. They call it the universal soil loss equation. And it's a model that tells you how much soil you would expect to lose depending on land cover, how steep the land is, how intense the rainfall is, and whatever other conservation effort you have. And of course, it would depend on the type of soil and so on, but we'll not go into that detail. What I want to tell you here is there is a model for soil erosion, or models for soil erosion, or a class of models that you can use. We can put these different elements together to track the dynamics of the soil quality or stock, and then analyze how a profit maximizing farmer, just like we did with the fishery, to find out what a profit maximizing farmer would do to manage the soil. And of course, there is a choice of strategy. Just like in the fishery, we could use a steady state strategy where we are looking for a set of management setup where we maintain the soil quality, we maintain what we do year in, year out in terms of what we put into the soil and how we manage it. And that's a steady state. Of course, you can also have a myopic one where you don't consider the long-term consequences, or you have some haphazard strategy where you try to maximize what you get out of the land. But that comes in so many forms. That's not a good way to analyze, just like we saw with fisheries. So in short, we can sketch out the elements of a model for a soil management problem, and then we can use it to find out what an optimal management would look like, and then we can compare with what we see in reality and see if farmers are doing the things that economists would expect from rational optimizing agents or economic agents. So what have we learned from the research so far? Well, briefly, what economists have found is that conservation behavior of farmers in places like Africa, example Malawi, might not be optimal as a steady state strategy. So they are not going for the full optimization where their actions are such that they take into account all the consequences of what they do and the benefits of current actions in the future. But at the same time, they are not myopic either. They don't completely ignore the consequences of what they do now on future fertility. So they are not static in their view, which means they consider only what happens now and don't care about fertility tomorrow. So the main message is that farmers take soil degradation costs into account, but only up to a point or to a degree. So what that means is, because there is an element of mismanagement in there from the society's point of view. Okay, if you look at what would be best in terms of social outcomes, in terms of soil management, you could do a better job if you manage the soil in a way that reflects the consequence of all the current management practices. Well, then you could say there is a room for policy intervention. Farmers are not managing things optimally, so governments could try to alter their behavior so the management outcomes are such that they are socially beneficial. Okay, how? Well, farmers may be mismanaging the land because they don't have enough cash. So credit services is important. They might be mismanaging the land because they don't understand the dynamics in the soil. Then farmer education is important. Farmers might be mismanaging the land because they are not secure in their ownership. In that case, improving land security, land titles is important. So point is, there is a shortfall in terms of how far farmers go to manage the land, and that means that governments should try to improve soil management by encouraging farmers by different means. So in summary, soil management is critical to food security, biodiversity, carbon sequestration, and water quality management. Soil degradation is a serious problem throughout the world, both poor and rich countries. Farmers' management of soil quality can be studied using models similar to those used in fisheries. Policy and institutions are important to what happens to soil because they affect what farmers do. Therefore, they should be a target for improvement if land management is going to improve. I need to mention that soil is an asset that has different characteristics. Even if you look at just fertility, there is an array of variables because you could look at nitrogen, you could look at potassium, other elements, you could look at soil organic carbon, and so on. How do you summarize all this in something called S or stock? Well, that's not an easy thing. So we pretended we could do that when we were talking about the modeling, but in practice, that's a difficult thing. And that's something that scientists have been trying to solve, and not for modeling purpose, but even simply to summarize how good a piece of land is, how fertile it is. So if you have all these different measures that reflect what the nutrients are, how do you summarize that into a simple measure called soil quality or soil quality index or soil quality indicator? Well, I did some work years ago on this to show basically from the economics perspective, using economics models called production frontiers, how you could do a better job of summarizing soil quality attributes into a summary measure, and why that approach was better than what the soil scientists were doing. And this article on Farm Weekly came in 2008 when I was starting to work on this, but 4 years later there was an article published in the Journal of Productivity Analysis called a Lowenberger Soil Quality Indicator. Now there is a PhD student in our school doing similar thing, but using data from Pakistan. But it's possible to use mathematical models to construct soil quality indicators. So I thought I would just finish off with that one.